Static grass can be a great way of enhancing your dioramas. And the best way to apply static grass is with a static grass applicator. Hello everyone, I'm Matt, this is Model Minutes, and join me on the workbench today as I explore a budget way of creating a static grass applicator for your modelling dioramas. So the static grass applicator I'm looking at today is something that has been designed to be very budget friendly. The casing is completely 3D printed and is available for free as a download. So if you have a 3D printer at home, this will cost you almost nothing to print out. How do you get these files, you might be asking? Well, as far as I know, all you have to do is sign up to the Beacon Models newsletter on their website, and they'll send you a link where you can download the files to this and also get some files for some other things as well. There are also some comprehensive instructions which I actually used to complete this project. So in this video I'm not going to be doing this as a tutorial, more as an exploration of the product. Also, you're going to need some electronic components. Fortunately, there are some components out there which can be bought as a pack. And again, these are not particularly expensive either. So having a DIY static applicator which you've made at home may be a much more cost-effective way of having this kind of product rather than having to buy something off the shelf. But anyways, let's explore this a little further. I've already printed out the relevant parts from the Beacon Models download folder. And I did print them out a little while ago, and my printing knowledge was not great, so the prints are a little bit ropey in places, but I think that they'll work just for this build. I've also been very kindly provided with the electronic components, free of charge, from Beacon Models in order to complete this project. However, all opinions do remain my own. You are going to need some extra bits and pieces though. Generally, you're going to need a soldering iron and some solder, some wire cutters, some extra bits of wire, and a little bit of knowledge about soldering electronic components together. But let's now start exploring the build. As previously mentioned, the instructions are fairly comprehensive, so I'm not going to do this as a step-by-step tutorial. Instead, I'm just going to explore the different aspects of this particular project construction. So there are going to be times when you might need extra bits of wire, so I found that tinning the ends of the wires is definitely going to be beneficial, so that they're ready to be soldered into the various places. You get a little socket which is going to allow you to have a probe extending from the device later on, and you need to crimp some wire onto this. This can then be glued in the hole that is intended for it in the relevant 3D printed part of the casing. This can be electronically powered either by a battery or by a 12-volt external power supply. So there is a socket for this as well, which gets some wires attached to it, and then this can also be mounted inside the casing. The main component that makes this work is this negative ion generator, and this has a mounting point specially designed for it. In my case, I simply snapped it into position, but you could glue it or screw it in using the holes. And there is a rocker switch which allows you to either turn off the device or select between the external power supply or the internal battery. This has relevant wires connected to it, following the wiring diagram and the instructions provided by Beacon Models. Make sure to do this through the hole for the socket, so that you can mount it when you've added those wires. Before you can do that though, you need to make sure that you've inserted the 9-volt battery clip and soldered that on to the socket as well, which can then be clicked into place. There are 2 LEDs included, one green, one red, and these just indicate which power supply is being used, just to prove that the device is working. I used a little bit of contact glue in order to hold them in place. In order to give your static grass its negative charge, a washer needs to have a wire soldered onto it, and this wire will go into the body of the device and give that grass its negative charge a bit later on. I used some more contact adhesive to glue this onto the relevant 3D printed part and pass the wire through the hole in the centre. I then moved on to attach the wire for the probe onto its socket, and there is also a crocodile clip which can be soldered onto the other end. This allows you to attach it to your diorama to give that positive and negative charge for the static grass to work properly. A small jig is included in the files which you can print out, and this allows you to mount the diodes that are included in the electronics pack. Following the instructions, I inserted these into the relevant holes in the correct directions and then soldered them together. There are some resistors which are also added into this jig and then soldered into place. Beacon models have been pretty clever with how they've designed this. Everything has a place and fits pretty well. They've tried to make it as simple as possible. This jig can now be mounted into its slot in the main body of the device. At this point, things are going to start looking a bit untidy in there, but as long as you trust the process and follow the instructions, you should get all of your soldered wires and connections in the correct places. Of course, you are provided with a circuit diagram as well, which I did refer to a couple of times just to make sure I was getting the right wires going to the right components. So at this point now, I've effectively wired up the resistors and diodes, and now I can do the same with the LEDs. Making sure, of course, to use a little bit of the leftover wire from the leg to attach it to the negative point on the rocker switch. The positive legs of the LEDs are then added to the resistors. Now I can turn my attention to the ion generator. I connected the ion generator's white wire to that wire which I attached to the washer earlier. But you do need to make sure that you do this after you pass the wire through the main body of the device. Having done that, a little bit of electrical tape could be used just to insulate the connection. Now I can join the main body onto the housing for all the electronic components, and that component containing the washer was glued inside of the hopper. This is going to hold all of our static grass in a minute and give it that negative charge. 4 small screws can be used to screw the casing together, which allows you to gain access to it if you need to make any electronic repairs or maintenance in the future. I connected a 9-volt battery into the bottom of the device and added the 3D printed end cap. And a quick flick of the switch, and yeah, it seems to be working. Well, at least the light is on. So what I need to do now is actually give it a quick test. I've decided to make a small diorama base using this piece of wood, and I put down some brown paint and mixed in some matte Mod Podge. This will give something for my static grass to stick to. For the static grass, I'm going to be using this Hornby Scale Scenics product, and this was loaded into the hopper. Once I'd put a suitable amount of static grass in the hopper, I added the mesh which goes over the top, and this sort of acts like a sieve for when you apply the grass. So I turned the device on, I popped the probe onto the base to help transfer the static charge, and then sprinkled the static grass all over the base. And yeah, it seems to be working pretty well. Looking quite close up, the static grass seems to be standing on end, and has given a more 3-dimensional look to the grass on this little diorama. So yeah, I'm pretty happy with this. This is definitely something that I'll be using in the future in some of my diorama builds. And for the sake of 3D printing some casing components and purchasing a relatively inexpensive electronics pack from online, this does seem to be worth the couple of hours that I invested in creating this. All in all, not too bad. I would perhaps like to revisit this in the future and make my 3D printed case a bit more refined, but for now I can live with the slightly untidy casing that was printed. After all, it's not what it looks like, but how it works. That's more important. I think it's probably time to wrap this one up here. Whilst this did present a little bit of a challenge for my soldering skills, as I have not done that in quite a while, following the step-by-step instructions that Beacon Models have provided, I did find that I was able to successfully create this project. It's fantastic that you can get the 3D printed case, which is specially designed to house all of the electronic components, completely for free just by signing up to their newsletter. And also the electronic components, being as cheap as they are, means that this is going to be inside most people's budgets. I'd like to extend my thanks once again to Beacon Models for sending over the electronic components so I could have a go at this one. But let me know down in the comments, is this something that you'd be keen to have a go at yourself? And do you think a static grass applicator like this would be helpful for your projects? I will of course leave links to everything underneath the video. As always, a quick shout out to my Model Club members for the extra support they give the channel. Massive thanks to these guys on screen, and if you'd like to join them, check out the links in the description. And there are other ways you can help support the channel. Once again, full information is below the video. The best way to support the channel for free though is by subscribing with notifications turned on so you never miss a modelling upload. Last thing to say though is a massive thank you to you for watching this one, and I'll see you on the workbench again next time.